As usual with these problems, we want to start by setting those variables, right? So I'm going to since we're maximizing, I'm going to choose x values. So I'm going to let x1 equal the millions of dollars in commercial loans, and x2 will be the millions of dollars in home loans. And now we write our constraints. Since every $1 million in commercial loans requires 2 lengthy application forms, and every $1 million in home loans requires 3 lengthy application forms, and the bank cannot process more than 72 applications at this time, we're going to have this constraint: 2x1 plus 3 times x2 has to be less than or equal to the 72 applications we can do. So there's our constraint on the number of applications. Also, they tell us that it's the bank's policy to loan at least 4 times as much home loans as they do for commercial loans. So the number of home loans has to be greater than or equal to 4 times the number of commercial loans. So make sure you wrote that correctly, right? So they're saying at least 4 times as much for the home loans, right? So you're taking the home loans are going to be 4 times more than the commercial. Okay, so I suspect some of you might have written that backwards, but think about it in terms of, so think about it just for a single value. If they were only going to do 1 home loan, right, then how many commercial loans could they do? Well, let's do it the other way around. Sorry, that was a bad example. If they're only going to do 1 commercial loan, they need at least 4 times as many home loans. So if 1 commercial loan, so if x1 was 1, then x2 would have to be at least 4. Right? And 4 times 1 would give you the 4. Okay, next constraint, we have that because of prior commitments, at least 10 million of these two will be used for these 2 types of loans, but we also have a maximum of 25 million of these loans. So that when I add these 2 loans together, the number of home loans, the number of commercial loans, it has to be less than or equal to 25, but also greater than or equal to 10. So we have a compound inequality. I'm going to think of this as x1 plus x2 is greater than or equal to 10, and x1 plus x2 is simultaneously less than or equal to 25. So this one inequality, compound inequality, is really 2. And for our objective function, we want to maximize the interest, right? So we're going to maximize, we'll call it z, 10% on commercial loans, so that's 0.1 times x1, plus 12% on home loans, so that's 0.12 times x2. And of course, we also have that our variables are positive. Okay, and so again, as I've said in the past, like this is really the key to me, that you guys can take a word problem like this and write down all this information. From here, it should be very much procedural. Now we are setting up the simplex tableau. So writing these as equations, we have to add a slack variable to this first one. We have to subtract 4x1 over to the other side and subtract off a surplus value, because this is greater than or equal to. For this greater than or equal to one, we have to subtract off surplus value. Sorry, and that should be a 10. And then for this last one, we have to add a slack variable because it's less than or equal to. So we take this information coupled with what we need to maximize. So remember, to maximize, we're going to bring the x1 and the x2 over to the other side. And so this is going to become our simplex tableau. So here's our simplex tableau. And so we write down our basic solution, which unfortunately has a negative basic variable, so this is not feasible. And so we look at this S3 column with the -1 in it. Oops, sorry for that, crossing that out, -1 in it. And we choose an element in this row that's positive, except the 10, so between these two, and that's going to be our pivot column. So I'm going to choose the first column, just to stick with the book's convention of going with the leftmost column. And so now we look at quotients. So actually in this problem, when I look at the quotients, we normally wouldn't consider dividing by a negative. And in fact, I even said in an earlier video we shouldn't do this. But when we do 0 divided by -4, we are going to get 0, and that will be the smallest. So I am going to actually pivot on this row right here. And in fact, because I've done enough of these problems, I'm actually going to jump to the last tableau and expect you to fill in the details in between. Okay, and in about 4 rounds of pivoting, which takes a while, and including getting through stage 1 and onto stage 2, we do finally land upon this final tableau where we have no negative indicators. So let's write down the solution. and we see that X1 will equal $3 million in commercial loans. X2 will be $22 million in home loans. We do have one positive slack variable, but that's fine. And we get an optimal value of $2.94 million in interest earned by the bank.